Hello and welcome to ISOmath. Today we're going to be talking about angles greater than 360 degrees. If I take my unit circle, which I have here as a radius of 1, remember all points on the blue around the unit circle make this true, have a radius of 1 from the origin. But if I want to talk about, say, a degree of 40, an angle with a measure of 40 degrees, remember I'm going to measure all my positive angles from the positive axis and I go in the counterclockwise direction. That gives me a coordinate of 40 degrees, or an angle measure of 40 degrees. Now there's corresponding angles. Obviously I can have a negative corresponding angle. Just as a refresher, the negative corresponding angle starts at the same place. We always start from the positive x-axis, but I'm going to go in the clockwise direction. So the negative corresponding angle to 40 degrees goes around that way. And basically it's 360 degrees minus the 40, so that's going to give me a negative 320 degrees is my negative corresponding angle to this 40 degree angle. But the really question is, is there another way we can measure that angle? And the answer is yes. Another way I can get to this angle of 40 degrees if I still start at the same starting point, which is my positive x-axis. However, this time I'm going to go one full revolution around the circle and then pick back up. So what in this case, what I've traveled is I've traveled one full revolution around the circle, which is 360 degrees, and then I went an additional 40 degrees, giving me a total of 400 degrees. And I end up in the same place that I did with my corresponding 40 degree angle. I can continue this, and I can actually go around not once, but I can even go around twice. And if I go around twice, that time I went 360 degrees, plus another 360 degrees, plus a 40 degrees. And that gives me a corresponding angle of 760 degrees. So ultimately, to come up with my formula for finding out multiple choices for an angle corresponding to such a radius, it ends up being your 360 degrees times n, however many times you go around revolve around the circle, plus your original angle, which we're going to call in this case theta. And that's how we come up with multiple choices for angles corresponding to a single radius. This is true for the negative version as well. We saw that starting at the positive axis and going in the negative direction, or the clockwise direction, that gives me an angle of a negative 320 degrees. Well, if I continue this on and don't stop there, and I continue one full revolution and come around again and terminate at the same ending point, I now have traveled a negative 320, the original negative 20 degrees, plus an additional negative 360 degrees because I'm traveling in the negative direction. This corresponds to an angle of negative 680 degrees. And just like the revolution, the formula for basically 360 degrees and plus the theta will correspond to negative values also. This n in this case is going to be negative values, the negative revolutions, and that's how we end up with a negative 360 degrees. So they are true as well, and that formula works as well. Hope this helps, and look forward to seeing you on the next lesson, which is length of circular arcs. And remember to stop by ISOmath for any of your math needs. See you next time.